So the topic for today, we will keep it simple and straightforward. So there are some questions which are asked, which are in direction of how this artificial intelligence can help me and how I can graduate towards it. Probably you are in an area where you are doing some work, maybe in a testing background, database background, or any application development background. Like how do I graduate to that is also an ask. So what I'll do is I'll keep it simple. We will discuss about different application areas of AI and how that is disrupting the industry and how these application areas are changing the day-to-day life and how we can graduate it. In the end, I have created a couple of slides where which talks about what are the important areas which we need to know for graduating into some of these application AI and data science and so on. Okay, so this artificial intelligence was there for many, many years. It is not new. So if you've seen, there are a lot of hype cycles which were there in past years, and they used to call us AI winters. For many, many years, the data analysis was there, data science was there, artificial intelligence was there for many years, and people have been practicing. But only in these recent days, people have identified that with a combination of big data, with a combination of cloud and the available data. So this is like a deadly combination where we have good amount of data available, we have good amount of infrastructure available to host the data, and also a good set of algorithms which can run on these cloud systems. So this combination is deadly, and that is the reason people are very bullish that AI will be leading in a couple of years, and it would be a mainstream for many years to come. And that gives us a confidence that we would be able to set up ourselves into the job market, or we would be able to use this particular area for sustaining for many years to come. So that is the future. So if people talk about AI, machine learning, deep learning, data science, so these are like different topics people talk. So AI, to break it down, it is more of a umbrella. It is like the general techniques, and which are general techniques which enable computer to behave, identify logic, apply rules, and do an automated way of doing things, right? So recently you might see some application areas where things are being automated, so generally in the testing or application automation and so on. So things are being automated. In olden days, people used to call that as AI, and nowadays there are a lot of automation, greater level of automations coming. But if you take a broader perspective, AI is more of making a set of rules and logic and rule based engineering, in which we try to put these logic and rules in computers, and computers will take this meaningful decisions to drive an outcome. So that is what a artificial intelligence mean. But there are some subsets of that which are now emerging a lot. People talk about machine learning. So machine learning, what it does is, machine learning, instead of doing a set of rules, set of guidelines, machine learning tries to identify patterns between the data. So that is the beauty of machine learning, where it tries to identify how these input and output are related. And then based on these relations, it tries to come up with a generalized approach or formula, and applies that formula for the future events. So that's the reason it is called as machine learning, where the machine here represented as a computer. The computer automatically understands the patterns between data and then comes up with a generalized approach. And that approach is implemented for all new data points which are coming to it. Now, it could be predicting who would be, so whether a person could be given a loan or not. And if at all he can be given a loan, how much we should approve. Is it like $100,000, $200,000? How much I should approve him? Do you think a person will pass an exam or not? Yes or no? Do you think, looking at these tumor data, can you say that this particular patient is malignant or benign? So these are some of the examples, but there are plenty of examples. We will look at it. But all these things are driven in such a way that machine looks at the data, identifies the pattern, and then instead of human giving any clues saying that this is how a tumorous cell would look like. This is how a loan approval process works, or so and so forth. It would be fed with plenty of data, and then it tries to identify the patterns in the data and then take a meaningful decision. Now, that is a section of machine learning. People also talk, there is something called as deep learning. Deep learning is evolving a lot in these days. Deep learning talks about uh, more detailed or more complicated data points. For example, can I look at image and then identify whether this is a broken limb or not? Like, I'm looking at an X-ray image, and then should I identify this is a broken limb or not? Looking a self-driving car looking at um, a traffic light, and then decides whether it is a green signal or a red signal, and based on that takes a decision to go forward. Like, these are some of the technology areas which involves a lot beyond the traditional row column data information which is provided. Like, it is not provided in a databases, it is more like an image, it is more like a video, it is more like a speech, right? I'm calling my Alexa and saying that what is the weather today. Now, how does then Alexa identify my sound, and then takes the sound, synthesizes it, and then do a Google call, and then gets me back a data saying that today's weather is 32 degrees centigrade. Like, how does that do it? So the data points, whatever we are using, are more image based, speech based, video based, and so on. So a lot of deeper technologies are used in this, traditionally called as neural networks, and that's the reason the name came deep learning, which goes beyond a regular identification of data points and looks at the patterns of images, videos, speech, and so on, and then does the decision making. So deep learning talks about that. So when even more deeper algorithms are used, deeper data points are used. So data points means I mean to say that images, videos, speech text, and so on, right? So such kind of things are used for performing even better things. And overall, artificial intelligence works on multiple areas. So from a business perspective, people could be asking simple questions that, who is the customer should I send my lead form to? Like, who is the potential customer who will buy my product? So such kind of questions are from the business perspective, but there are also questions from business perspective or a healthcare perspective, like looking at certain kind of images, MRI scans, and then detecting certain elements in the body, right? So those are some of the application areas. We will see it in the course. So people thought that AI was there for many years, and this graph shows that there were certain AI winters. AI winters talks about there are some areas where it went down and then again came up. And now are we in the situation where we anticipate that there will be a continuous growth in the AI. I already told about the reasons, that we have a couple of reasons. Abundance of data we have availability of hardware, whether it could be a disk or a disk for storage, and compute for the RAM and other things for compute. And we also have a lot of algorithms people are developing from the past couple of years. Like, Google has invested heavily in developing algorithms, which are to directly use those algorithms and work on their business problems. So likewise, it is actually accelerating a lot. So that is the reason you might see all these kind of insights that people are looking at AI as a different thing, because it is going to change the world. Now, why that is important? Now, the data is there everywhere. People have understood that the data is increasing tremendously, and with the increase in the data, it is now even more advantageous to take the benefit of AI. Now, I'll skip through a couple of the slides which are very generic. So this talks about like what are the different types of data which AI generally uses. Transactional data is one of such thing, our regular business processes. So people are still having a lot of data in the transactional thing. So if I'm a retail shop, what is my transactional data? I'm buying a 1 kg sugar. I'm buying wheat, I'm buying rice. So this is my regular transaction data with a retail shop. If it is a bank, I'm withdrawing 100 rupees, I'm depositing $1,000. So this is my transaction data. So most of the businesses still work on this data level. But even in this data, we wanted to identify the patterns, and then based on that, take some meaningful insights and decisions out of it. Next data, which AI is very concentrating, is on the audio and the experimental data. Audio data, you might know the examples like now people are shifting towards, previously people used to have websites and a lot of data gathering used to happen on websites. Then there is a great shift in from website to mobile based environment. Like now people are using mobiles for doing development, like app development scheme, and people are using these apps. They're not going to laptops or going to the websites, and you see the lot of data is on the apps now. There are some applications which are not having any website, but nowadays there is a shift in the data, shift in the trend, which they technically call as no UI. That means that we are not going to use any app or website. We are going to ask devices directly. So you might see Alexa and connected devices like connected TVs, connected cars, and so on. You directly talk to them. And coming are the years where most of the devices which we are seeing around us will be connected, and then you can talk to them. So there is a lot of experiments happening in the direction. A lot of companies are working in this to work on the audio data. So how it can understand speech, and then using the speech, how it can take the decisions, and then based on that work on it. A lot of experimental data is also used. For example, if you see a lot of current experiments are being done in COVID and related vaccines and so on. And it tries to identify a lot of patterns. A lot of statistical analysis is done in that, like identifying whether the particular gene is positive or not. And then if it is positive, how it will impact the human, whether the results will be positive or not. So a lot of clinical trials are happening. Similarly, a lot of data analysis happen, which uses machine learning and AI in this particular field. Other data areas are video and image data. Video data is about lot of surveillance information, camera capture, CCTV capture, and a lot of video data, media data. A lot of those applications are using video analysis. Similarly, images are being used. For example, you might see that Facebook is tagging your friends automatically. You might see that you can open your phone, show it to a particular language, and you don't know Tamil, but you show it to a Tamil language, and that gets automatically converted into English or any other language of your choice. So such kind of applications are being developed, which actually uses video and image based data, and then convert that into your usage. And the applications are being built using AI, with which we can do all this work. Similarly, there are different types of charts, graphs, statistical analysis which could be provided. All those things are provided using AI, and which will give a trend or forecast of what is going to happen in the future. And then based on that, businesses can take some meaningful decisions. Now I need to know Maruti sales are down. Now I need to know on June month or month of May, how many sales could happen, considering the impact of COVID and other things, like how many sales could happen. And then based on that, how much production should I make, right? So if those are the questions businesses have, the data will be able to answer that. And using all these statistical analysis, we can give some meaningful analysis or meaningful numbers. Likewise, I'll also talk about how it actually emerged. So far, so good, right? Any questions, you can stop me and ask. But is it good so far?
Yes, Sitaram, it's good.
Yes.
Yeah. So I will just talk about like how it already happened and how it has progressed in progress in the years. So it all started with a lot of these social media companies who are having tons and tons of data. A lot of these companies are having different problems. For example, if you take Facebook, it is about friends, linkages, images, videos, and so on. YouTube also has the same content. It has plenty of video content, Now, how do I recommend same videos to somebody, recommend necessary videos to people, and so on. If you take Google, Google have plenty of pages to index. It has a lot of emails which it is getting. So all these emails have to be identified, which are spam, which are not spam. So the problems they had were different from a traditional company, which is uh, just a second. So the problems these companies are having are different when compared to other companies that generally doing business based on the proper data they have. So they have invented a lot of technology. They have invented a lot of tools and algorithms which are able to work on these kind of data. Okay, so that those are the ones. Those have become pioneers for bringing in these new technologies, the artificial intelligence, machine learning, deep learning based algorithms, cloud-based systems, big database analysis systems, and so on. So all these things which are very heavy, data heavy, were bought by them. Now, once they have bought these systems, people started questioning, like, if I have all these tools, like, what can I use it for? People like banks, insurance companies, and other major media companies, retail companies, they were asking this question, that how could I use these technologies? So what they did is they found out one application area which they were using for many years, called as predictive analytics. Like, they were saying that, okay, if I can use this tool and technology, how can I predict what is going to happen in the future? Like, who are my potential customers? How many cars I could sell in the month of June? Whether this customer will buy my product or not. Which movie is going to get hit? Who is the actor who is going to perform well? Like, who is the player who is going to perform well, and so on. So you see that a lot of these predictive nature has come into picture, where the people are trying to get the data, get as much as data, and then using these new set of algorithms and tools, trying to identify or predict which is going to happen in the future. So the other companies, the primary banks, insurance companies, retail companies, those actually used these technologies and then created a lot of applications. Another set of companies which wanted to understand, again, banking and insurance based companies, telecom based companies, they used this use cases of fraud detection. And fraud is very important, because many companies wanted to know whether there's a fraud happening or not. So a lot of algorithms are there in the AI community, like outlier analysis, anomaly detection, and so on, which try to identify these anomalies. Anomalies are nothing but uh, data points which are not following a regular trend, right? They are very different from the normal data points. So if I group all the transactions which are happening, if I try to plot them in an n-dimensional graph, you would see that most of the data points follow a clear trend, right? They will be grouped together, they have a clear data, and so on. But there will be some data points which will be away from the group, or they are following a different trend. Technically, those are called as outliers or anomalies. Anomalies are like, a customer who is a regular spender, who goes to the shop, spends $100 and $100 weekly or by week, $100 a week or something, and he does his monthly spending could be somewhere around $2,000 $3,000 with all the basic things. But suddenly his credit card got a swipe, and then there is a $5,000 withdrawal. And such kind of things are anomalies, right? Regularly you're spending for gas, food, different other things that don't cost much, right? A couple of dollars here and there. But if there is a sudden swipe in the card and you're seeing a $5,000 transaction, then that is an anomaly. Typically, such kind of anomalies are identified, and then suddenly things would be alerted, your card would be blocked, you would get a call for authorization and things like that. And then based on that, things will be taken forward. You might also see anomalies detection by Google. For example, I'm not sure in other countries, but typically if you go and try to surf Google from another place or a internet cafe, so you would get an email to the Google authenticating the transaction, right? So whether you are the person who is accessing the Google or not, right? Because Google knows all our data points. It knows what are the actual data points and what are anomalies. So it will know your IP address, other things and all. And then based on that, it tries to identify the anomalies or not. So such kind of cases are there which identifies these changes, and all those things are done by artificial intelligence applications. One other important application which uses artificial intelligence is natural language based sentiment analysis. Like if you see, most of the applications we are using are having a customer facing. It could be Amazon, it could be Netflix, or it could be any of the media sites, YouTube or things like that. So if you see, all of them collect a lot of reviews, right? And reviews actually gives a lot of strength to the customer trust levels. And if I want to understand from a customer, like, whether the review is a positive, negative, or a neutral, that is like a basic analysis, basic sentiment analysis, which will be done. So I used to work on a project back in 2010, when our customer was asked to create this voice of the customer portal. So the customer was a basic car rental company, and they used to rent cars. And back in those days, we don't have a greater penetration into the web market and all. But people were asked to go to a particular website and then provide a feedback. And then we were asked to take the comment and then try to understand whether the sentiment of the particular comment is positive or negative. And we used to tag those sentiments to the particular location. So for example, you're renting a car in London Heathrow or New York City or anywhere. So you have good experience, then you put a positive comment there. So by station, you will be able to tell that this particular location is having positive sentiment, this particular location is having negative sentiment. But nowadays, the sentiment analysis has gone leaps and bounds. People don't just want to get sentiment like positive, negative, and neutral. They want more deeper analysis. They want to go to something called as entity level analysis. Now, I want to buy a mobile. Now, I go to the Amazon.com and then go through the comments. So one thing which I would really like to see is what part of the mobile is good, what part of the mobile is bad. For example, you're looking at a comment saying that the front facing, the look and feel of the mobile is great, the build quality of the mobile is great, it is very sturdy, and the pictures it takes is crispy, and so on and so forth. The battery life goes for 2 days and so on. But in the end, there is something like a comment saying that, but the front facing camera is very awful, right? If the comment goes like this, like with a couple of positive points and ending with a negative sentiment, you really wanted to understand like what is positive and what is negative in that, right? From a customer perspective, I want to know that build quality is good, the battery backup is good, the pictures are crisp, but the front facing camera is awful. Probably they have kept a 1 megapixel front facing cameras. And nowadays, everybody is a selfie freak who wants to take selfies, and the front-facing cameras are very important. So they want to better front-facing cameras, right? So you see that from a customer perspective, it gives a pinpointed information, and also from a manufacturer perspective, it gives a clear customer sentiment, like what customers are liking. Now, if they know that, okay, everything is good, but the front-facing camera is bad, what they will do is the next version, the yes version, which comes next after your every mobile release, that gets a 25 megapixel front facing camera, and your product would be a hit. Now, what we are doing here is just trying to understand or gauge the sentiment of users based on the comments and text provided. And a lot of companies, because they are customer facing, try to do a lot of these things and give some general ideas, give some give all these kind of analysis, so that they can give both to the customers and to the manufacturers the real information in a very easy way. So likewise, there are some applications which could be used. There are classification and clustering applications. These are some of the important applications in artificial intelligence, which tries to classify into one or the other categories. Like I was saying, looking at a tumor cell, can I classify this is a malignant or a benign cancer, right? So that is how a classification talks about. And if I look at a group of customer records, can I group them that these are high spenders, these are low spenders, these are medium spender customers? Such kind of analysis will be done. So there are techniques like classification and clustering which will do all this work. And during the course, we would also learn all this thing. One other important application areas are recommender systems. Like, how do I recommend things? If I know that these two products are relatable, like if I'm buying a bread, I might certainly buy jam or butter and so on. If I'm buying certain things, there is a high probability that I buy something else. Like you go to Amazon, you're buying a mobile. In the bottom, if you scroll down, you will see that people who have bought this mobile also bought this scratch guard and also bought this case. Now, how do they know that these are the good combination? Like people do something called as there are algorithms which are like association rule minings, which are again part of artificial intelligence, which try to identify the association between the product. If there is a high association between the products, product A, product B, and product C, then I can say that people who buy a product A are most likely to buy product B or C. Likewise, there could be a lot of these recommendations. Now, the recommendation could be like people who buy this can also buy this, but the recommendation can also go like combo offers. Like if you buy this toothbrush, you get this toothpaste with 50% off, or the other way around, right? If you buy this toothpaste, you get this toothbrush with 50% off. Like if you buy this Ashirwad Atta, you get this oil for 20% discount, right? So you see all these kind of offers which are made, and people are able to relate products very easily because the help of the tools which are available right now. With the algorithms, we can easily able to relate products which are clearly unknown before. And there are a lot of examples, because the time is limited, I can't talk about that, but I hope you're getting the gist. So recommendation engines are the algorithms which are used. So there are other application areas like car sharing industries, the new drive sharing industries, driving taxi shares, and so on. For example, Uber tries to identify like when to bump up your price. For example, depending upon the demand of the customer, depending about the time of the day, the location, and other things, it has an automatic algorithm which bumps up your price. For example, you got down out of a train in Hyderabad, and then you're waiting for booking a cab. It knows that by that time, by that place, by that area, you would have a lot of car bookings happening. And based off the surge in the price, it will bump up your price a lot. Previously, it used to use a different search algorithm, but nowadays, using the artificial intelligence, it exactly knows like how many people are booking, what is the location, how many cars are around. Based on that, an automatic search price is applied. Similarly, it also knows like where will be the next booking which will happen, the probability of a booking happening. Imagine there is a financial district, there is a IT hub, and then every day in the evening, 5 to 6, there are a lot of cab bookings happening. With this past historical data, it can understand that every day during this time, a lot of cab bookings happen, and this is the time where I can send the cabs to this place. Similarly, there could be a very busy nightlife in New York City. Saturday night, there's a lot of cab bookings happening in a specific street or an area. So it knows that by this time, by this place, there are a lot of cab bookings happening because people are getting drunk and then they use cabs. So they exactly send the cabs there. A lot of technology is being used in the same direction for getting a lot of such kind of services. One other important area which I am also fascinated is human emotion analysis. Like looking at people, can I understand their emotions? It's a very difficult question, right? People are very tricky. But can computer do that is a big question. There are a lot of application areas, a lot of companies which are working on this thing, because in the coming 5 to 10 years, you would see that a lot of customer facing people will go away. Now, what does the customer facing people? As somebody you're going to a hotel and trying to book a room, the people who I'm talking, like customer service agent, the receptionist or somebody, right? I don't need a receptionist. I can just talk to a computer. which can understand my, probably look at my face, identify who I am, or I can talk to them, give my reservation number, and then ask for a sea facing room, right? So I can do that directly with a computer. So a lot of monotonous manual jobs which currently we are doing are going to replace, and those are being replaced with a lot of these computer aided humans, which talk, understand, feel like humans, and then able to serve people. Like it could be a receptionist in your hotel, or it could be a bank cashier or teller. These are people, or these are the jobs. I'm not saying people. These are the jobs which might get vanished in the coming years, because those are very monotonous, and computer can do in very well, provided it understands human emotions. So there are a lot of these works which are happening where the computers can look at human faces, understand the facial expressions, understand whether they're happy, sad, angry, understand the voice modulation, and then based on that decide whether the person is happy or angry, and so on. A lot of work is happening there. Very interesting area. One of the work which I did in 2012 2014 era is genomic data analysis. This is a very interesting project, and of course it is very important for the current age, current situation we have. Genomic data analysis, what it does is it exactly help in the drug discovery phase. Like it is the place where we're trying to reduce the drug discovery time. Like for example, I want to invent a new virus, a new vaccine for COVID-19. Now, what should we do? We should go to some clinical trials. So what are these clinical trials? Now I invent a vaccine for COVID-19. I can't directly test it on COVID patients. Why? Because if I test it, there could be some side effects. Person can die. So I don't want to risk that. So typically what happens is the test happens on different animals. Like it gets tested on mouse, rat, rabbit, monkey, and chimpanzee, and then to humans. So there is a cycle in which people follow, the drug companies follow this cycle, and then after that they go to clinical trials. Clinical trials are like you take sign from the patients that I am aware that this is a new drug, and then if something happens to me, I will not sue the drug company. So that happens. Now currently the COVID vaccines are in the clinical trials. I think China has uh, sent some invite saying that there is a new drug accepting for clinical trial right now. So this is the process it follows. But the important thing is we need to know like what genes in these animals are similar to humans. Like for example, if you see a rat, rat is having eyes, rat is having nose, rat is having mouth. It is eating. It is having the digestive system, and everything else happen, right? So similarly, those are the similarities between the rat and the human. Of course, the shape, look, and feel of the rat is different from the human, but there are some similarities. Some genes are similar. So the project which we did was identifying these gene similarities, and then identifying the drug impact on the gene similarities. Like if there is a positive impact on the drug, the same thing would be impacting positively on the humans. Like identifying the data and then identifying the similarities of the data is a big chunk of the work which is done by data scientists. And artificial intelligence, there are multiple set of tools, processes which has to be followed for doing this entire work. We need to understand like how this entire stuff is done. Oh, so this project was a very interesting project, and it cut down the drug discovery time by a great amount. One other very interesting area, and I'm very gung-ho about it, is this Internet of Things. Internet of Things talks about how the world is going to change with everything connected to internet in the coming years. Like if I look around me, the laptop could connect to internet, the light could connect to internet, the microphone can connect to internet, the chair can connect to internet, TV, AC, fridge, everything can connect to internet, and in fact they can talk with each other. In the coming years, I might talk to my fridge saying that, do you have palak in you? And then it will say that yes, I have palak in me, and I'm just talking very superfluously, but things can happen like that. So I can ask fridge that do you have a can of beans, and and then it will say, yes, I have, in the third rack, and so on. And then it can intelligently order from bigbasket.com a bottle of jam in the future. And these are going to happen because a lot of these intelligent systems are coming. Because if you have can of beans, it has barcode scanners. So when the can of beans is going into the fridge, it can scan like what is this barcode, and by that it will understand what that product is. It can also have video sensors which can look at the products in the fridge. Now I have a jam bottle which is almost empty. Then it can understand that jam bottle is almost empty, and then can signal my account on bigbasket.com and order a jam bottle. Now, these all things are looking very, very superfluous at this point, but certainly they are going to change the world. And believe me, Internet of Things is nothing but every product around us is having some sensors. They're able to sense the environment and then can send that information to cloud through internet, right? So one of such projects which we worked using data science and machine learning is to predict which machine is going to fail in the coming 2 weeks, right? It's called as predictive maintenance of applications. And one of the car makers is the one in the project, where we have to identify like which machine is going bad. And there are these lot of devices which are connected to internet, and then there are a lot of these sensors which sense information of the device and then send back to the cloud. And once I get all the vitals of the machine, I would know that if the machine is getting overheated, if the lathe of the machine is not cutting the the part in a right shape, that is a bad part. And because of all these signals, we can identify that, okay, machine number 58 is going bad in 2 weeks. And then, please change the lubricant fluid in the machine or something, and so on. So all those instructions will go to the supervisor of the shop floor, and he or she will take care of the machine. So such kind of projects are developed in manufacturing industry, where we are trying to identify, trying to prevent, which is going to happen in the future, with the help of artificial intelligence and machine learning based tools. A lot of such kind of applications are being used. Very, very useful applications. Okay, let us also continue. So there are other applications, like you are very familiar with these. These are voice-based assistants, we call. I briefly touched upon no UI. So in the future, you would not be having mobiles, you will not be having computers, you will just be asking questions. Whom you will ask, God knows, but definitely that kind of stage will come in the coming years, definitely in our lifetime. So no UIs will dominate, where we are directly talking, we're directly thinking, and then our thought process get percolated. And primary application areas which are used are AI. One other interesting area which we have worked on for a biggest US hospital chain is to identify people and give personalized medicine, right? So those hospital chains have something called as EMRs. EMRs means electronic medical records. Now, if I'm getting admitted to a hospital, I will give a lot of details, like what is my age, what is my eating habits, drinking habits, lifestyle habits, what are my vitals, like what is my blood pressure, what is my blood group, and different other things, right? So there are a lot of vitals which could be gathered from every patient. And imagine I get fever and I was given aspirin or crocin or some Tamiflu, right? And I get cured. So that thing will be recorded. And if there is a similar kind of a person, right? If a similar kind of a person of my same weight, height, age, bodily conditions, my blood pressure, and similar conditions, if somebody else get admitted with the similar conditions of mine, and he also got fever or flu, and he's given a Tamiflu with the same dosage, then it will cure him. So the problem what happens is, one type of medicine doesn't fit everybody. For example, there is a very skinny guy and low age, low weight, and so on. And then if he has given a higher dosage of Tamiflu, probably one tablet Tamiflu, that might create a side effect for the person because he's low weight, he's having different bodily condition, and his blood sugar levels are down and things like that. And such kind of for such kind of a person, probably a different medicine would work. Maybe a one dosage of Tamiflu would not work. Similarly, if there is a very stout guy who is very hefty and he also got fever, and then you are giving the same dosage of medicine to him, probably it might not work on him because it is not at all working for him. His bodily conditions are different. His weight is different, his height is different, his blood pressure is different, and a lot of things are different. So hospital chains are working towards a direction in which they are trying to group people or patients depending upon their bodily conditions, and then based on that, identifying patterns in which cure can be done. For example, certain medicines work for certain group of people, certain medicines does not work for certain group of people, and such kind of applications are made using artificial intelligence to help doctors to give some meaningful directions. Like, it certainly does not replace doctors. Doctors are gods. It doesn't replace them, but it will complement their decision process. So it will make the decision process easy. So with the help of AI, a lot of such personalized medicine applications are developed by a lot of hospital chains in Western countries. Certainly, it has not reached India, but the things are changing and going to happen in the future. So these are some of the application areas which are important. And to sum up, a lot of artificial intelligence experts are required. A lot of companies are seeking for this kind of knowledge or technology application areas, and that's the reason we see there are a lot of job postings happening. And to understand a little bit what skill sets are required, it would require a good amount of math knowledge, good amount of statistics knowledge. Substantial expertise would certainly help. For example, if you have, like, say, 10 years of experience in some industry area, it should certainly add up your experience, and it will help you in long run. And there are a lot of hacking skills. For example, a lot of algorithmic skills which are required. So a lot of algorithms are used in machine learning, deep learning, statistical algorithms are used. Understanding those algorithms, when to use those algorithms, and to what situations to use those algorithms is important. And combination of all these things come up as a clear skill set. I'm calling here data science, artificial intelligence. These are all combined, connected together, and those are the ones which are used for a good career. So with that, I will take a stop